Okay, so let's start. Okay, so we will start. We are discussing factor analysis. What exactly is the process? Yeah. What exactly is the process of factor analysis? First, we saw why we do factor analysis, and the basic linear algebra we discussed separately over quite quite a few sessions. So at the end, we will see when we talk about rotating a matrix or eigenvalue, rotating a factor or eigenvalue. So that means it will be a lot more clearer than if we had not studied linear algebra at all. Yeah. So After that, we have begun with the process of factor analysis. Using Excel, we are seeing something. And when you use any software, say SS or SAS, SAS, so the outputs will make much more sense to you based on because of the basics we are going through, because of the basic underlying processes we are trying to understand. So the outputs. So what we do is we start with the correlation matrix. This is a very simple example of three variables, yeah, which actually does not require factor analysis. But for example of the calculations, we are considering this. So this is the correlation matrix. So how we do is we have added all these correlations under one variable, yeah, and then taken the sum of all these sums. Then while calculating the factor loading of the first factor, how we calculate is we divide the sum here 1.8 divided square root of this 5.4, square root of this grand sum. So this initially we get this factor loading, then we make a matrix out of this factor loading. Yeah, this will be in rows, this will be in columns, the way it is done here. Yeah, we have done this. Yeah. Then how do we get these? We just multiply the row value and the column value, corresponding row value and the corresponding column value. So here 0.77 and 0.77 are multiplied. If we go here, 0.81 and 0.77 are multiplying. So similarly, this matrix is created. The values inside the matrix is created. Then we repeat the same process as we did with this matrix. That is sum of all the values in the column, then a grand sum. And again, to check factor loading is correct, we do similarly. Here we have divided 1.78 divided by square root of this 5.34. So here we can see these values. Yeah. These values and the values here match. Then we say that we have got a factor loading for one factor. Otherwise, what we are going to do next, we do that till we get same values, these two. Yeah.
Sir, how did we get the 0.81 in the second column?
1.87
did we
divided by
get
square
that
root of
0.81?
5.34. 0.81. Yes, that's what I
Second
am
column.
explaining.
No,
Second
in the
column
column J, in the above the table.
here.
Sir, cell number J3.
J3 here. Yeah, it is this value only. I mean,
Yeah.
due to some rounding off, it has become 0.81. It is 0.82, right? Okay. Yeah. Maybe due to some rounding off, it had. Yes. Yes. Yeah. Okay. Yeah. Now it perfectly matches. Okay. I think while copying and reducing the decimal places, it became 0.81. Yes. Okay. Yeah. So similarly, the process we are repeating. Uh, one thing if in this matrix we would have made it positive, then went along the process. So here in the second first factor is done, we have taken factor factor loading for each variable. Yeah. From here, yeah, or from here you can say 0.77, 0.82, and 0.73. So we have got loading for factor 1. Yeah. So we proceed, we subtract this matrix with this matrix. So this is, yeah, okay. If there was some negative value, we would have made it positive by using absolute value function, then went along with that. Okay, so this is there. So here we have, yes, then as here there are negative values, we have made it positive by using absolute value. Yeah. Then repeating the same, sum of columns, sum of columns, sum of columns, these. Okay, to be consistent, we can have this outline. Yeah. So sum of columns, and then the sum of column divided by square root of this grand total of sum of columns. So here we got this loading. Similarly, how we made this matrix, the same way we are trying to make the matrix of initial loading we got. Let's see what happens. We will fill out these values like before. So if we want to drag it here, so I value I'll fix. Yeah. And here J value I'll fix. Here key value I'll fix. Yeah. Okay, I can reduce the number of decimal places quickly. Yeah. Yeah. Then loading check. Loading check gives us,
Sir, there are again different values. Like in place of 0.51, it's 0.50.
okay. Yeah, yeah, yeah. Ah, so this is 0.51. Yeah, so we have so less number. We can do this with hand manually. 0.64. Yeah. Okay. Thank. Oh, yeah. We have not got the final value. We are in the process. Yes. Okay. So I have not put it here. No issues. I'll put it here. Yeah. Okay. It seems to be some error. 9. Okay. Let me calculate. Yeah. Oh, yeah. Okay. So Excel is helpful, but it also accepts the values we give. Now what happened? अच्छा square root नहीं लिया. Yeah, yeah. Now it matches quickly. So we can take this value there and factor loading. Transpose rarely works. No. First we do. I don't know why transpose rarely works. Now it works. It has to be outside that. Clear contents. Control C. Yes. Control V. And we reduce the number of decimal places. Yeah. So this loading is done. Factor 2's initial loading is also done. Yeah. And fortunately, there is not cross loading. These two are nearby. So when loading on two factors are very near, we say there is cross loading. So this vector is equally explained by the two factors. So in which factor you will put this variable will be a confusion. So how do we deal with that? There is a simple solution. We will mention that in due course. Okay. Finding factor loading for second factor is done. Now for the third and last factor, because there are only three variables. So the initial matrix will be, there are no negative values here, but when progressing further, we will get back the negative values and subtract from that matrix. The original matrix, this matrix dot, we put here, and negative values in that, we will take the absolute value again. Yeah. So minus here. Yeah. Okay. चौथा भी आ गया. So let us check if it has. Yeah, corresponding values are right here. Okay, corresponding values are right. Yeah. So this is the matrix to start with for third variable. Okay. Yeah, that's a uh, family exclamation sort of for me. Yes. Yeah. So we'll again have this. Yeah. So here we will have absolute value. Yes. So this is the thing. Now let us see what happens. Sum equals. Now grand sum. Then the factor loading, initial factor loading, this one divided by square root of this and fix. That's it. Oh, okay. Acha, that cannot be fixed. Yeah. See, these are all Pokayuk mechanisms. Pokayuk in uh, operations we have studied, right? So you just cannot give the wrong input. Yeah. So again, we'll make a matrix of this. But not always. Everything in Excel is not Pokayuk, obviously. And here we can write factor 3. Okay. So here this multiplied by this and fix. Okay, here this multiplied by this and fix column J. Multiplied by. I hope it is clear. I mean, the process is clear by now, even though it is a very small example. Yeah. Yeah. Okay. Yeah. So ये नंबर सेम आ गया तो बाकी का भी it will be same. Still we will do the process because it won't take much time. Yeah. वो राउंडिंग में सेम हो जाएगा. Here we can have everything decimal. Yeah. So here we can see this value and this value. Same. We can do a little bit decoration here, which is seldom required, but very useful when we revise. Yeah. So this matches, so we can take this loading. Otherwise, we would have simply continued. The iteration doesn't differ in process. We have match, so we are taking this factor loading. Otherwise, the same thing we would have done without taking the factor loading till it matches. Yeah. 0.61, 0.61, 0.54. Because these are three variables, I am doing like this. Otherwise, we cannot imagine in actual research with 30 questions and 300 respondents, more or less. Yeah. Yeah. So this is our factor loading. Yeah. So this is our factor loading. Now, what all we can do, what all good things we can do. So in factor loading, what we do is we, first of all, square this first. Yeah. Now, the process here, from here, it becomes very, very important. Till now, it is behind the scenes. Now, what we are doing is actually we are going to use these. Yeah, so we can cap. Where is that signal here? Yeah, hope it works. Otherwise, okay. It is the same, right? Yeah. Okay. This is called the factor loading matrix. Upper one is called factor loading matrix or component matrix. In many softwares, you will see as component matrix. Matrix factor loading matrix. There is an important step, but we don't use it directly to find the other things. Yeah. So we square it and we call this matrix, this new matrix, by a different name. Okay, was it? Acha, uh, yeah, R square, R square matrix. So बाकी जो है we do the processes based on this R square matrix very quickly. Maybe our session will end before time today. No issues. That's a good thing. Yeah. So here we have eigenvalue. Here I'm just trying to name this as eigenvalue. Okay, this is an eigenvalue. We can try to discuss. So we are just adding this. Yeah. So eigenvalue. Yeah. Yes. Eigenvalue, and we can have the sum here. Next step we will be finding percentage. So Yes, this is eigenvalue. This will be used to decide whether to include that factor or to drop it. Okay, that to decide that. And variance explained, percentage of variance explained. From here we get, okay, what it means is, I will explain. Yeah, so we can convert it into percentage, which makes more sense. Yeah, we can keep two decimal places. So 48% is explained by factor 1. Okay. In the model, 48% of the variance is explained by factor 1. For 22% is explained by factor 2 and 28% is explained by factor 3. Basically, why we are talking about variance is whether two variables belong together, they can be put in one factor. How are we deciding it? Based on whether they are varying together. Yeah, whether they are varying together. So that is how we are clubbing the variables together. So that's why so much emphasis on variance. Yeah. When we are discussing factor analysis in any book, every 10th sentence will have this word. Maybe a little exaggerating. Exaggerating. Sorry. Yeah. But more or less, it is like that. So that is variance is very important. Yes. Okay, so variance explained as this. And there is something called as commonality. See, when there are different variables and a couple of factors, say, I'm just writing something here, not related to our earlier example so far. Yeah, so these are four variables and underlying factors are F1 and F2. Yeah. So in practice, in real life, these are the variables you will be able to see or measure, and factors you will not be able to directly measure. So that is why these variables are called indicator variables. And these are called latent variables or latent factors, hidden factors. Yeah. Yeah, that is one thing. And what I was saying is, yeah, so some part of the variance in V1 will be explained by F1, F2. Yes, not everything will be explained by F1, F2. Yeah, not all the variance in V1 will be explained by F1, F2. So the part of variance which is explained by F1, F2, part of variation in V1 which is explained by F1 and F2, that is called commonality for V1. Yeah. So that is part of variance explained by all factors considered. Okay. So this is called commonality, which coincidentally becomes very important term. It becomes a important term in factor analysis, commonality. This is common variance. This is also called common variance. And the other part, which is not explained by F1 and F2, that is called unique variance. Unique variance for V1. Similarly, there will be commonality of V2 or common variance of V2 and unique variance of V2, which is not explained by F1 and F2. Yeah. So for commonality to find it numerically, what we do is we do a simple addition of these. These are already squares. squares of the factor loading, and we are just adding this. Yeah. Okay. So yeah. Okay. So how do we use this eigenvalue method? We have studied in the last session how to decide on the number of factors. So wherever eigenvalue is greater than 1, we take that factor. So here, any doubts? There is a lot of time remaining, so uh, I hope the doubt is not concerning time. Uh, okay. Yeah, Deepesh, sorry, are you saying something?
No, no, sir.
Okay. Just a second. I'm uh, charging cable. I'm putting the charging. Yeah. Okay. So इतना तो हो गया. So in this case, we will be dropping this factor 2. Yeah. So that for that we have calculated eigenvalue. We can actually do that. We can so थोड़ा गड़बड़ हो जाएगी. So पर we can do that. Actually, I can keep this. No, I'll keep a copy of this at one place, one safe place. Yeah. Then we can do these things. So ये मैं निकाल भी दूँ. Yeah, it's not necessary. Yes. Okay. So now we have factor 1 and factor 3, which actually rarely happens because the importance decreases in sequence. But in this case, we have got like this. Eigenvalue was less for factor 2. Yeah. So variance explained by factor 1 is 62.69. Now this is the commonality. This is the total this thing. Yeah. Commonality, as you see, is decreased. So as we removed factor 2, all the variation in V1 are not explained. 0.3% variation are not explained. Earlier, if I, yeah, so earlier this much explained. Yeah. Okay. So this gets affected, that is not a concern. Yes. So like this, in this case, we have done a factor analysis like this. And there is no cross-loading here, that much of a cross-loading, although 0.5 and 0.40 will be considered a little closer, but not that close, not that much closer to call for any action. Yeah. So in this process, we have these two factors which we will consider. Okay. Now, what happens if there is cross-loading? So if there is cross-loading, we try to move the factor in such a way that the loading gets distributed in a clearer way. So how to do that? These factors are, we are calling it a factor. So these factors are actually vectors. Yeah. So basically we are arranging different vectors uh, in between, I mean, in the coordinates of these variables. Okay. factors are basically vectors. We are finding the best vector, which actually does not get that much affected by these variables. Yeah. So that's why we can have those factors as axis, and the coordinates from those axes to the variables we can see. And depending on whether uh, which variable is then closer to which factor. So we'll club those variables with that factor. If some other variables are closer to another factor, so we will club that variable to that factor. That is what we are doing in factor loading. So we will say that one load on factor 1. V2 also loads on factor 1. Acha, okay. So everything loads on factor 1. So although cross loading is not there, this problem is there. This problem is actually more common than we think. So as the process described, it finds the most important factor first. So it many times happens that all the variables load on factor 1. So in that case also we rotate the factor a little bit. So how to rotate such factors? How to rotate any vector? Yes, we should be able to arrive at this. You have a vector in a coordinate plane. How do you rotate that? By doing one or the other matrix multiplication, right? If you multiply a vector with a matrix, it gets transformed or rotated. Yeah. So we do that factor rotation. That is the elusive factor rotation you will be studying, and without uh, having discussed linear algebra, everything would have been a mystery. But now we can understand what is meant by rotating a factor and why we are rotating a factor. Okay, so we can discuss the process of rotating a factor a little bit. So for rotation, you need a matrix, right? Yeah. So I'll very briefly explain the matrix. That matrix is called transformation matrix. Yeah. So actually, we'll be rotating this matrix, component matrix, not this one. There's R square matrix. So this factor matrix, factor loading matrix or component matrix, we will be rotating with the help of a transformation matrix. How do we get that transformation matrix? Is we get the raw responses. So here we will get responses converted into numbers. Yeah. So in different kinds of scales, we will be using the scales which are metric, which are numbers, which make more sense as numbers, say not as colors, which are like nominal scale, which are called nominal scale. So four kinds of scales we have. Actually, have a look at the types of scales. There are four types of scales, and it's not difficult to see. Now we are directly getting use of those scales. Yeah, if it was related to some color, so who likes what color? So in that, we won't be able to use factor analysis because we won't have data in numbers. We will have nominal scale data. So here we need metric scale data. So in the four types of scales, two are called metric, where the numbers make sense, have some meaning. The difference in numbers have some meaning. Say one thing is 2 feet long and the other thing is 4 feet long. So the difference has some meaning. So it will be the same difference between something which is 3 feet long and a thing which is 5 feet long. The difference will be same. So those sort of comparisons can be done only when the initial data is in particular scales. Not every scale will allow us to use factor analysis not every scale will allow us to use all the research methods. Yeah.
Sir,
Usually, yes.
I have a doubt. Why
Yeah.
do you want to rotate the matrix, the scalar? I mean the factor one. Why do you want to rotate it?
Because everything will be in one factor, so it will not give us a clear picture what is happening underlying, what is happening behind the scenes. So one factor is affecting everybody, so that doesn't clarify the situation. Yeah.
Th then what would have been the condition which for which we don't have to go for the transformation? Then what is the ideal
Uh,
condition?
say if this was 0.66 here and 0.29 here. So at least in this small case, we would have said that uh, factor 2 loads on factor 3 and the other two factors load on factor 1. So that is all right.
So the reason we are going for transformation matrix is that because all the factors are loading on the factor one. That's why, and not on factor three.
Yes. Yes. All the
Then
variables,
okay,
yes, all the
okay,
variables are loading on one single factor.
okay. So it would have been loading on the both the vectors. Then we didn't go for the then we wouldn't have gone for the transformation matrix, right? Is that it?
Yes. Yes.
Okay,
We wouldn't have gone for a rotation of the factors and we would not have required transformation matrix. Yeah.
okay.
Yes. To what I was saying, how transformation matrix is made or something else. I lost track
Yes,
of
sir.
the.
The same thing.
Yes, transformation matrix, how it is made. So it is made with the raw data, raw responses, and scales. Yeah, that's for scales we got into. So it should be in metric scale. The data should be in metric scale. Uh, the things in metric scales. So we'll be taking the raw data and standardizing it. Standardizing means what? If say there are this kind of data, 9, 10, yeah. So these are not serial numbers. So 45, 67, जो भी हमको डेटा मिला है बिल्कुल raw data from the respondents. Yeah. So we will sum this. Standardization means the same. We are finding out Z values. If we substitute each of these values with its Z value, so we will have a sum here. We will have a standard deviation here for each of these, for here and for here. For both of these, we will have this. And then if we find, if we draw a parallel thing, so this value minus the sum here, minus the, I'll better write like this, sum or average rather, yes. So this should be average. Yeah, not sum. Sum divided by the number of variables. That is the average. That is the X bar we call. So value divided by average of that uh, value divided by the standard deviation. For each of the values, we substituted. Yeah. Yeah. So I'm just trying to make it clear. For here, we will substitute it with its standardized. So we'll have a standardization matrix. Okay. So that standardization matrix is actually can be used as the transformation matrix. So that we multiply the factor loadings, this matrix with the transformation matrix and get a little rotated factor. Okay. So commonality is covered, eigenvalue, percentage variation explained, how to choose the number of factors. Yeah, so now the process is, the underlying process is clear. Any software, actually to learn a software, to learn any process in a software, if you start learning SPSS, to say that I know SPSS, it will take a long time. But I know how to use SPSS to do factor analysis, it will take hardly a couple of hours, a maximum couple of hours. Some of you can learn it in 1 hour or so. Yeah, so that is not a big deal. You can do this. And matrix multiplication, okay, yeah. So here you will need to multiply to rotate. Basically, you will need to multiply. So how to do that? How to use Excel to multiply that? So for that, I have this small example again. Let us see that. We have some time. Yeah. So this is a matrix. This is a matrix. And this is a matrix. So can we multiply that? In school, we have discussed, yeah, 3 by 3. So number of should be equal to number of rows of the other matrix. Then we can multiply. And the resulting matrix will be 3 by 3 matrix and 3 by 2 matrix. So ये अंदर का और ये second value and the first value will go away. So the resulting matrix will be 3 cross 2. Yeah. That you understood what I said. So if it is 3 cross 4 matrix, clear, right? Or is there any doubt?
Yes, sir. Yes.
Yeah.
Yes, sir. Clear.
Yes. So yes. So when you discuss amongst yourselves in your study group, so let the application projects group or your life projects group, mini application projects group or your life projects group also be your study group. So when you're discussing in your study group, you explain it to someone if it is not clear to him or her. Yeah. Yes. So here we have to multiply. We want to multiply. How do we multiply? Is there is a function. Yeah. No surprise there. M mult, matrix multiplication. Here what we do is we select the matrix and this matrix, first that matrix, comma, then the other matrix. Then we select enter, which gives only one value. What do we do is we do F2 और इसका जो dimension है, okay, sorry, here we can do M multiplication, comma, here, okay. Then we select the required dimension. It is going to be 3 by 2. So 3 rows and 2 columns. So like this. Then what we do is we put F2 and then there is a command, Control Shift Enter. Control Shift Enter. Yeah. So it actually gives this matrix. I affected it earlier, so you can check the values which are same. Yeah. So this is the product matrix. Yeah. Now the benefit will not be apparent, but when you are multiplying a 10 by 10 matrix with another, say, 300 by 10 matrix, it will be, you will be much more thankful that this function is there in Excel. Yeah. You can try this out. A book command if you can write, I'll also write it for your reference. So you do that multiplication, use that function m mul, yeah. Then it will give just one value. Then you select the dimension. Then you press F2, yeah. Then Control plus Shift plus Enter. It will fill the matrix command, Excel command. Yeah. Yes. So this much is required as a base for factor analysis. In the next session, we will revisit a little bit of linear algebra. Uh, yeah, and see eigenvalue or rotation ka. Actually, rotation we already discussed. Let's see. Yeah, otherwise we will start with regression, regression output. Yeah, regression output, how to read, how to make sense of the regression coefficients, especially when there are many independent variables. Yeah. So here, although factor analysis and regression are different, yeah, so when we can say that variable v1 is explained this much by factor 1 and explained this much by factor 3. So including factor 1 and factor 3, we can sort of make a regression equation to explain variable 1. So that is why in some books you will find very hazily they will mention that factor analysis has regression as its backbone or as the underlying process uh, without explaining what it means. But this is what it means. So if we want, we can treat factor 1 and factor 2 sort of as independent variables and try to explain these variables based on regression equations involving factor 1 and factor 3 as the independent variables. Yeah. That is not in clash with anything we have discussed so far. Yeah. Regression and factor analysis are indeed different. In regression, you need to have independent variables which should not have any correlation. So here factor 1 and factor 3 should not have any correlation in between each other, with each other. Yeah. Okay. I hope. Yeah. So yes. So apart from regression, our course is almost over. I had requested a, very nice person to have qualitative analysis discussion with you, but she is suffering from COVID in Delhi. So I am approaching another expert. She might be discussing something else, not qualitative analysis. Maybe, yeah, some data analytics technique or AI related technique, applied AI, which everybody can understand. Let's see. I mean, I'm not assuring, I'm not promising an expert for research methods in this semester, but I'll try to get somebody. Actually, everybody does research, but to call somebody to exclusively discuss research is slightly difficult as it is turning out. I'm just sharing. Yeah. Okay, but we'll see. Yeah. Okay, then. Yeah, go ahead. And you have, I think, IoT lectures you have at 3:30. Before that, you will have the regular session, and then there is our question and answer open house as a part of Deep Sea Talks. So everybody be there and enjoy. If after joining you come up with some question, then also you can ask. So only the time will be a restriction. Pawar sir has said that as much as questions students have, he will take up. He will try to answer. Yeah. Okay. Yeah. Any doubts? Any observations? Otherwise, we proceed for lunch. Acha, okay. People have started exiting. Okay, yeah. So we will have a recording of this to go through again. And please make use of your study groups. It's different, it's quite different when you do it, when you explore things together.